Hello, students. In this class, we are going to deal with some examples based on truth table. Okay. So, in the previous classes, we have discussed the logical uh, conjunctions. Okay, proportional logic and conjunctions, disjunction, negation, and the various relation on these. Okay, and we have also discussed some truth table with some examples. Uh, in this lecture, we are going to deal with logical. Okay, let me check it. Logical equivalence. What do you mean by the logical equivalence? So, if two prepositions, if two prepositions P, capital P, small p, q, and this and that, where where small p, q are propositional variable, are propositional, okay, propositional variables. Have always identical truth table. Have always identical identical truth table. Truth table or truth table values. Truth table or truth values. Then the prepositions, then preposition are called logically logically equivalent, and it is denoted by P is equivalent to Q. Okay. For example, prove that the following prepositions are equivalent to. Prove that the following prepositions are equivalent to are equivalent to, that is number one, negation of P and negation of Q. The second one, negation of P or Q. And the third one, negation of Q implies negation of P. We need to discuss here that the proposition P implies Q is equivalent to this. It means that the truth table, all the four relations are the same. Okay, now we check it for the solution. and it's very simple. Okay, now here we P and Q. As we know that there are four cases, that is P may be true. Okay, we take here small q. Okay, and T may be true. Then P may be true, T false, or P may false, T true, or both may be false. Okay, so now simply negation of P. So it's false, false, true, and true. Then negation of Q, false, okay, false, true, false, then it's true. Negation of Q. Let me check first, is the screen is shared or not. Okay, it's good. So now we check P implies Q. Okay, or, or P, P. First, we try to find out the P and negation of Q. That means here we are using the conjunction, and in the case of conjunction, if one of them is false, if one of them, uh, if both the are true, it means both. Okay, if one of them is false, then it is false. Okay, if one of them is false, then it is false. So what about this P and negation of Q? It means it is false, then it is true, and then it is false, and then it is also false. Okay. If one of them is full, then it is false, or both the false. Okay. Now, if you talk about the negation of P and negation of Q, so it's simple. It's true, false, true, then it is true. Now, so it's the first one. What about the second one? That is negation of P or Q. Okay. Negation of P or Q, it means that if one of them is true, then it is true. Negation of P and Q. So in case of negation of P and Q, so it's the negation of P and it's the Q. If one of them is true, then it is true. So it is true and it is false and it is true and it is true. Okay. So now third one. Third one is that negation of Q implies negation of P. Okay. So negation of Q implies negation of P. So if both the false, then it means then negation of Q implies negation of P. Okay. So in that case, it is the conditional connectives, or in the conditional composition, we see that if one of them, if both the true, then it is true. Okay. So if both the false, then it is false. So it is true. Okay. Then uh, it is false. Okay. It is false. Okay. And it is true. And then it is true. Okay. Now, if you talk about the P implies Q. So P implies Q, we can write here. Okay. P implies Q. P implies Q. So in case P implies Q, both are true. That it means then it is true. Okay. The P is true, Q is false. No, no. it's false. Okay. Uh, if P is false, then Q is true. Yeah, it's true. Okay. Both the false, then it's true. So we see that here that P implies Q. The values, the truth values of P implies Q are the same as the truth values of negation of P and negation of Q. Okay, negation of P or Q. Okay, negation of Q implies negation of P. Therefore, these all are equivalent. So it's the truth table, and these fours are logically equivalent. Now, the next question is that here we will discuss another one question. Establish following equivalence using truth table. Establish following equivalence using truth table. Using truth table. Number one, negation of P by conditional Q is equivalent to P and negation of Q, or negation of P and Q. Fine. And the second one, P or Q implies R is equivalent to P implies R and Q implies R. Okay. And the third one is P implies Q or R is equivalent to P implies Q or P implies R. Now, the solution, and the first one is P Q, है ना? Possibilities true, 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 false, and false, true, and it is true, true. Okay. So, and in the same time, we try to find negation of P. We'll need it. That is false, false, and okay. It's true, true. It's false, false, and it is true, and it is true. Then we write negation of Q. False, true, false, true. Okay. Then we find biconditional P if and only if Q. Okay. P if and only if Q. So P if and only if Q. So if both are true, then it is true. If both are false, then it is true. If one of them is false, then it is false. So in the first case, it is true. In the second case, it is false. In the third case, it is also false. In the fourth case, it is true. Okay. The negation of P if and only if Q. Okay. So it is false, it is true, it is true, it is false. Now, next, P or negation of Q. Pure negation of Q. So P or negation of Q, and we are using here the connectives as conjunction. So if in the case of conjunction, if one of them is false, then it is. In the case of conjunction, if one of them is false, then it should be false. Okay. We are talking about a P negation of Q. P and negation of Q is that. So it should be false. Okay. And it should be true. And it should be false. And similarly, it should be false. Okay. If both are the true, then it is true. Now, negation of P and Q. Negation of P and Q. Negation of P and Q. So negation of P and Q. So negation of P, this one, and Q, this one. So one of them is false, then it is false. So first one is false, then second one is false, and then true, and then is false. Okay. So next one is mm, next one is what? P or sorry, P and negation of Q or negation of P and Q. Okay. Now we find the relation in this one and this one. So if one of them is true, then it is true. So it is false. One of them is true, then it is true, then it is true, and it is false. So uh, we see that uh, negation of P and Q, this one and this one. These two are logically equivalence. Okay, the negation of P by conditional Q is logically equivalence to P and negation of Q or negation of P and Q. So similarly, we can try to find out this truth table for the second one, and the second one is that now we write the second one here. What about the second one? So let me see the second one. Okay. So second one is that P or Q implies R. P or Q implies R. It is equivalent to P implies R, P implies R, and Q implies R. So it's quite simple. Here we will write the, because here we have the three prepositions. Okay, three preposition PQR. Okay, so PQR. Then the relation true and false will be, I think, around it's around 8. Okay, so first case may be true, true, true. Okay, then it may be true, true, false, and then maybe true, false, true. Okay, then false, true, and then true, and then false, true, and false, and then false, false, and true, and then false, false, and false. I think it's 1, 2, 3, 4, 5, 6, and 7. So one case we have lost. Okay. So it's what? It's What about the case? True, true, false. True, true, true. True, true, false. Then true, false, true. Okay. Then false, true, true. False, true, true. Then false, true, false. Then false, false, true. Then false, false, false. Okay, it's good. So if we talk about the P or Q, so one of them, if it is true, then it is true. So it is true, and it is true, and it is true, and it is also true, and it is also true, and then it is false, and it is false. Now, P or Q implies R. Pure Q implies R. So pure Q implies R if we talk about conditional. Okay, conditional. So it's true, it's false, and it's true, false, true, true, then true. Okay, so guys, you can do it by your for your practice. So I think we should not move for the long discussion on this on the truth table, and you can draw, or you can picturize, or you can logically design the tabular table by using some examples, by doing some practice. Okay, so next in the sequence we will study about converse, inverse, and contraposition. Okay, converse, converse, inverse, and contraposition. Converse, inverse, and contraposition. So, what do you mean by the converse? Okay, the converse of P implies Q. The converse of P implies Q is Q implies P, and inverse, the inverse of the inverse of P implies Q is negation of Q implies negation of P. Okay. Third one, contraposition. Okay, the contraposition of P implies Q. The contraposition of P implies Q is negation of Q implies negation of P. And there is a mistake if we talk about the inverse. So it is negation of Q implies negation of Q. Okay, it is negation of Q implies negation of Q. So these are the definition of converse, inverse, and contrapositions. So here we will try to understand these three with the help of an example. Okay, example. Let P implies Q let P implies Q if ABCD A B C D is a square is a square, then it is a rectangle. Then it is a rectangle. Then it is a rectangle. Write its converse, inverse, and contraposition. Right? Its converse, inverse, and contraposition. Okay. So for the solution, P implies Q. है ना? For the part of converse, that is P implies Q means Q implies P. Okay, Q implies P. That is इसका मतलब क्या हुआ? If ABCD, if ABCD is a rectangle, then it is square. Okay, so it's about the converse. Now, what about the inverse? So, inverse is negation of P implies negation of Q. What does it mean? If ABCD is not a rectangular, if ABCD is not a rectangle is not a rectangle, then it is not a square. Then it is not a square. Okay. And contraposition, that is, what do you mean by the contraposition? That is, negation of Q implies negation of P. If ABCD is not a rectangle, actually, in the case of inverse, we did some mistake here. If ABCD is not, uh, above we have discussed the contraposition part actually. Okay, ABCD is not a square, then it is not a rectangle. Huh? So in the case of contraposition, it will be if ABCD is not a rectangular, okay, then if ABCD is not a rectangular, then it is not a square. So it's quite simple. Right? Here we can try to understand converse, inverse, and the contraposition again with the help of an example. Uh, Another example, like if 3x plus 4 equals to 10, then x equals to 2. Find converse, inverse, and contraposition of given statement. Find converse, inverse, and contraposition and contraposition of given statement of given statements. So let P 3x plus 4 equals to 10 and Q is x equals to 2. So if P implies, then P implies Q. What does it mean? If 3x plus 4 equals to 10, then x equals to 2. What about the converse part? Okay, what about the converse? Converse is that Q implies P. That is, if x equals to 2, then 3x plus 4 equals to 10. Okay, what about the inverse? How we'll write the inverse? So, if we talk about the inverse, then we will define it like this. Inverse, that is, negation of P implies negation of Q. This implies that if 3x plus 4 is not equals to 10, then x is not equals to 2. Right? And the fifth one, contraposition. Sorry, third one, contraposition. That is, negation of Q implies that negation of P. That is, if x is not equals to 2, then 3x plus 4 is not equals to 10. So guys, these things are very simple and you can try to solve and try to write converse, inverse and contrapositions of any of these things. Okay. So here we are going to deal with another one example. Um, and I'm giving you the another example. So it's for your home assignment. Just try to this like question. The contraposition of a statement S is given. Okay. Then write the statement S and its converse. Okay. It's a very good question too. The contraposition the contraposition of a statement S is given as if x is less than 2, then x plus 4 is less than 6. Okay. Write the statement S and its converse. Very good question. Write the statement S and its converse. Okay. Another question I am writing here for your practice. Draw the truth table for draw the truth table for P implies Q and its contraposition converse and inverse. Converse and inverse. Guys, I think you guys are now able to design a truth table for this, and I hope you will enjoy. You have enjoyed this lecture, and if you have some problems in any in any concept, then you can raise the questions in the comment box. Okay, so keep learning, keep growing. See you in the next video lecture. Thank you very much.